Okay, this is March 30th, 2015, and this is Aaron Murakami on the phone with Eric Dollard. Can you hear me okay, Eric?
Yeah, if you speak up a little louder or closer, it'd be better.
Okay. So the purpose of this call is we'll put this talk on the Indiegogo campaign so people can understand what this AM radio experiment is about and why it's relevant to the seismic project. Now, first of all, I have two video clips that I got from Justin. One shows you with a little handheld pocket radio tuned to the AM band, and it has some wire wrapped around it, and then you connect it to some ground lines, and suddenly there's like a channel on, every single frequency as you're thumbing through the stations, which wasn't there before. And then there's a second video where you're doing some tests. Looks like you're doing using an ohm meter to check the resistance between different points on there, and then it looks like you have one of Steve McGreevy's devices that you're using to listen to some signals. So what are people seeing in the video clip where you where you have some wire wrapped around the AM radio and you connect it to the ground line?
Okay, what's going on there is first the AM radio was shown to be receiving in its normal mode. Some explanation is required. The AM broadcast band operates what's called medium wave or medium frequency. The wavelengths are fairly long, like 1,000 feet or so. And basically the medium wave band is defined as being between 300 kilocycles and 3,000 kilocycles. So 1 megacycle is in the middle of the AM radio band. So it has a coil inside of it because there's no way to build the structure of that wavelength size to receive electromagnetically. So the handheld AM radio, pocket radio, receives magnostatically, to use a technical term for it, in that it receives the magnetic field, but it is not receiving the electrostatic part of the electromagnetic wave, just the magnetic part. So it's a compromise antenna. But it has hundreds of turns on it, and it has a concentration core of magnetizable material that effectively makes it a 1,000-foot wavelength device. So when this thing's held up, you can take any pocket radio and you'll observe that as you turn it, there'll be a dead spot when the windings on the coil are not in line with the tower at the AM station. Then if you turn it 90 degrees, it comes in good. So that's kind of shown first with the radio above ground and limited reception available. There's several stations of moderate strength. Then after that, the telephone cable that's being paired out and worked on and refurbished, there's two 6,000-foot sections called H loading sections. And there's a ground rod on the end of each one, and then what I do is I take a piece of wire and I connect the shield of the eastbound cable to the shield of the westbound cable and make a loop to create a magnetic field, and then immerse the coil of the AM radio in that magnetic field. So now the AM radio is magnetically coupled. It's 12,000 feet of underground facility, and then it's noticed that the AM radio receives all stations, all channels are full, the full volume, and this is done with the cable that's buried 18 inches to 3 feet in the ground. So it demonstrates pretty clearly that there's a very strong underground component to the AM radio broadcast.
Which is not typically known.
No. That's that particular element of AM broadcasting is in the Tesla mode, and that mode has been stated by the Einsteiners as to not exist whatsoever. So the entire wave is conceived as being external to the Earth, but that's actually not the case. There's a longitudinal dielectric wave that transmits from the ground system, the AM radio station, into the Earth. And my crystal radio initiative that I started on the energetic forum was aimed at actually extracting useful power as in the Tesla wireless power transmission mode from AM radio station in the town of the person doing the experiments, and people were capable of lighting small light bulbs and running very small motors off of power extracted from the transmitter at the AM radio station transmitter site, which basically vindicates Tesla's conception of telluric transmission.
Now, when powering the light bulbs from this ground component from the AM radio transmission from the station, would that be drawing a load on the station? Like the station would be...
It'd be insignificant because the station, is typically putting between 5 and 50,000 watts into its antenna. The bulk of that power is consumed as energy, wasted by electromagnetic radiation in the space, but the Earth component is not necessarily wasted. It bounces around inside the Earth, so that power is, or the energy is conserved, so that particular power does not represent a power loss that the power bill representing at the transmitting station. But if you connect a resistance to it or a load like a motor or a light bulb, then that is a very small percentage of increase in power consumption from the AM radio station via the telluric wave.
Mm-hmm.
So it did work, and it shows that, the Tesla transformer and an appropriate ground system will receive and transmit tangible quantities of energy through the interior of the Earth.
Mm-hmm.
So this is what I'm proposing as a maritime communication system where the hull of the ship, which is in very intimate electrical contact with the conductivity of the Earth, is utilized that mode is utilized to transmit to the ship. And then the idea is, if Tesla was right, and the wavelengths are long enough or the frequencies are low enough, then it's quite conceivable that the radio receiver can be powered by the transmitter, and it will need no batteries or external power source. But I'm not in a position to do that right now because there's too many obstacles and things that I don't have.
Mm-hmm. But this ground transmission is obviously pretty related to the advanced seismic warning system.
Yeah, because Earth has its own natural waveforms, so it's alive all the time with a certain amount of earth currents and piezoelectric surges and so-called lightning strikes and magnetic storms, and this stuff, is various peaks and nulls in this stuff depending upon solar flares and all kinds of different types of situations. So, but the Earth is literally alive with electricity in its interior, like it is externally with, the numerous lightning storms and tornadoes and hurricanes and other things that kick up an incredible electric commotion. So they actually kind of work just like with the AM radio station having an overground and underground component. It's the same thing with the electrodynamic process of the Earth. Is the overground and underground have a dynamic relationship between themselves and produce these complex electrical waves, and the aim of the telluric project is to receive the natural signals of the Earth rather than the man-made signals that are transmitted into it.
Mm-hmm. So with the seismic project, you'd have lines, stretched across the telephone poles, and then you would have ground rods going 30 feet into the ground. Is that to pick up above ground and below ground, and then that way you can see actually the whole picture?
Well, the whole thing with the telluric antenna structure, which I developed at Landers, is to separate the overground and the underground, so you can tell what's what. And that's part of what's shown in the video. I think in the third part is how that works out. So the Alexanderson structure receives nothing from the overground. It receives strictly from the interior of the Earth, but the Beveridge transmitting structure receives from the overground, but receives very little from the inside of the Earth. Unfortunately, at the surface of the Earth, where the boundary condition exists, you have a refraction of overground and underground to overground, so it takes a kind of a sophisticated antenna system to separate those two. The separation is never going to be complete. It's going to be about 20 decibels down in the antenna that's not supposed to be receiving it, so then you use various networks to phase that out at the terminal building so that you get strictly overground and strictly underground. And then you will find that a lot of the things that people attribute to having an overground origin, like, the musical signals the Earth makes during magnetic storms and earthquakes and all those things, actually is not overground, it's underground.
Mm-hmm.
So in the third part, I use Steve McGreevy's device, which is electrostatic, ungrounded. I did not connect it to any type of ground other than me holding it. And that responded to the overground impulses, and then I had a Western Electric Type 3A noise measuring set that has a low impedance, and connected that to the telephone cable sheaths, and that was the underground component. And at that point, I think it's shown, either with myself or Justin, that one ear has an overground headphone and the other ear has an underground headphone, and then the dimensional stereo results where you're hearing the underground overground complex in stereo, and it helps you identify what's coming from where. And indeed, all of the harmonic signals emanate from the interior of the Earth, and all the impulse signals emanate exterior to the Earth. So that was pretty much demonstrated there. Another thing that was demonstrated is these devices, which are fairly popular, such as the ones that Steve McGreevy has constructed, have a certain defect in them that's nearly impossible to get out, is the fact that there are higher frequency impulses of roughly around 18 kilocycles, actually rather violent electrical discharges of pretty strong magnitude, sometimes enough to reattach loose connections on telephone lines. It'll actually spot weld them together. They can reach peaks of about 300 volts, but they're not audible in themselves, but the enormous magnitude overloads the solid-state devices in the detecting apparatus, kind of like the detector in AM radio, so the high frequencies are converted into audio. So a severe complication with receiving both underground and overground is to have the necessary filtering and gain and bandwidth specifications so that your device does not convert the high frequencies into audio, and then you're listening to phantom signals that have no physical existence. They're generated within the receiving device themselves. This is something that has been completely ignored in any of the research in this area.
So with the now, when you're holding Steve McGreevy's device with the antenna extended and it's got a little speaker built into it, then you start petting the dog. I think that's Justin's dog, and then you can actually hear the signal.
Yeah, well, petting the dog creates a massive electrostatic disturbance because there's about 20,000 volts being generated, and then the sparks and discharges create all these displacement currents. So the overground device is immersed in the dielectric field of the Earth at that spot, both from the lines of force emanating from the interior of the Earth and the lines of force emanating from outside the Earth, from the ionosphere. So the dog simply becomes a nodal point in that. So its electrostatic or dielectric field is coupled to the radio. So anytime there's a shift, like the process of raising the voltage, petting the dog, and then the little sparks creates these displacement currents, and then that causes current to flow in the antenna of the radio, through the radio, and into my body, and then that's what you're hearing coming out of the speaker.
Uh-huh.
So now if there was a vein of some mineral inside the Earth, that's being stressed or cracks or something due to some kind of seismic activity, that will also cause a dielectric shock wave, and then those lines of force will tend to radiate outwards from the Earth. So at the Earth's surface with an electrostatic receiver, such as the one demonstrated, you're getting that refractive component of where the inside meets the outside. But it's predominant on the outside. Now, conversely, the telephone noise set is not electrostatic. It's electromagnetic. It's got a transformer winding in it. And that is sensitive to the actual electrical currents that are flowing in the Earth and the magnetic fields that are associated with that current. Now, a common way that is method that's utilized to receive that is instead of using an electrostatic antenna, you use a magnetic loop, and then you lay the magnetic loop on the ground, and then every electric current is associated with a magnetic field. They cannot be separated from each other. They're married permanently. So if there's a current flowing in the earth due to some kind of telluric process, that current is surrounded by loops of magnetic force, and then you orientate the magnetic coil, loop stick coil in the AM radio, or the air core coil used in the earth signal receiving methodologies. Then you're getting a better idea of what's going on in the ground, because that relates to current flow. And then what you can do is you can put two of them at right angles, and you can actually get a stereo representation of the current directions in the earth, or you can do like we did in the video, and you can have a multi-dimensional stereo where one is electrostatic and one is electromagnetic. In this case, I'm not talking about electromagnetic waves, but electromagnetic induction. And then you have that type of stereo. So it can get really interesting when you start combining all this stuff together and get composites.
Right. Yeah. Steve McGreevy sent me some photographs, and it looks like he uses two big loop antennas.
Yeah. So what happens with those loop antennas is the magnetic lines of force from a current inside the earth, or changes in the magnetism around the earth, inducing currents. So you have a situation where a current can be produced inside the earth due to a lightning discharge or a telluric manifestation, which will give rise to a magnetic field surrounding it. Or you can have a situation where there's a magnetic storm on the earth, and the earth's magnetic lines of force become tweaked, and you start to see the compass rock back and forth. That induces currents in the earth. So it's a reciprocal relationship, and the cause can be either one way or the other, and ultimately cannot be separated. It's a chicken and egg type situation. So it's very difficult to define which is the cause and which is the effect, because they really work in tandem. So there's a lot more study that needs to be done of these phenomena to get a better grasp of them, but the antenna structures to really do this properly are enormous. So the loop that has to be built consists of 4 25-foot utility poles, the normal 5 feet in the ground, 20 above, and then a 15-foot square of 600-pair telephone cable with all the pairs configured in series parallel to make them a giant winding, and then 2 of those at right angles to each other, and then those go into the amplifiers and demodulators and all that type of stuff, and then you can really get an idea of what's going on with the magnetic field, and then you can use differential ground rods for the current, and then you can use the Alexanderson antenna for the radial component of dielectric waves emanating from the interior of the earth, and then you can use the Beveridge antenna as electrostatic capacity between the earth, the ionosphere, and the sun to receive that, and then when you composite all these things, you can get some very fantastic resultant signals. So this is what I was doing at Landers.
Okay. Now with the seismic project, some people don't realize that the seismic part of it is just one application of this system, and there's other experiments you're going to be able to do with this type of setup. What is an example of 1 or 2 type of experiments you could do that's not directly related?
Well, the thing is, this all found its origin in an office in the RCA headquarters in San Francisco between me and Jim Hepburn, the district vice president. So the complication that existed was the satellite thing was putting all of the HF radio out of business. And RCA was moving in the satellite direction and was looking forward to me being an engineer to put their station together for them. But also, Hepburn was an experimenter and kind of thought the old school way. He really felt that there was an alternative process of communications that would still involve the regular radio frequencies, and my mission was to figure it out. At that point, neither one of us knew about Tesla. And of course, being young at the time and myself being swayed by, the normal philosophies of looking at things, I was immediately going for, tricky modulation schemes and, to spread the bandwidth and all this type of stuff, and not thinking about the actual transmission process. But by the time I got my laboratory together out at RCA, I had rediscovered Nikola Tesla on my own prior in high school with RCA's generous donations of laboratory equipment, and I picked that up, and that's where I learned about this new mode of transmission. It was supposed to be directly applied to ship-to-shore communications, but between Commonweal and Greenpeace and a number of other factors, the station lost its license and was barricaded by these people, so now that process can't go on. But that's what we were after, a ship-to-shore communication system that used a novel form of transmission. Then I rediscovered Tesla, and he provided that novel form of transmission, and Marconi and Alexanderson had laid the 750,000 square foot ground system at the station in Bolinas, which would facilitate such a transmission. So that was my main objective. But then when I got set up at Landers, the interest there was more orientated on the noises out of the Earth as, kind of a scientific thing and a background deal to be going all the time for basic entertainment, if nothing else. And then the whole emphasis shifted on the earthquake thing, which is something that, ultimately people are more interested in the ship-to-shore communications. But I still, have the aim of devising a ship-to-shore communication system using this mode, and that's part of the purpose of trying to put a laboratory together here. Is I have these big gas tanks buried outside the building from when it was a car dealership, and I also have a metallic connection to the original gas lighting system here in town, and that will facilitate an experimental transmission into the Earth, even though ultimately it should be done on the coast, but you can't do anything on the coast anymore because of the socialist takeover.
Now, what's the now people, you're mentioning lightning strikes, and a lot of people are familiar with the Schumann resonance, and they don't really think about how that's actually calculated or what it even means. And supposedly the average frequency is about 7.83 cycles per second. What's wrong with that picture?
Well, Tesla points it out right in the very beginning, is that the gap between the ionosphere and the Earth is a very tiny one. In fact, it's extremely tiny. And when you're talking about electromagnetic wavelengths at 7 cycles a second, you're talking about enormous distances. And these distances just simply don't exist. You cannot have a waveguide mode unless between the boundaries, that length represents a significant fraction of the wavelength. So the whole Schumann resonance idea doesn't really work out too good. So it's something more going on that involves the inside of the Earth. These are the things that I'm specifically after and studying, if I can ever, get the full-size, antenna and transmission structures constructed, which would have to be rather enormous. So the ones that we have now are compromise situations, of leftover telephone debris in neighborhoods that might not necessarily be conducive to doing this type of research because of enormous power line interference or inability to electrically communicate with the inside of the Earth because of the nature of the rock or whatever, but that's all I got. So at any rate, it will allow me to build representative systems, but not what's really needed to get into a full-blown study of this stuff, where you have to have about 3 or 4 mile-long structures, and you have to have these telephone cable loops and all this type of stuff, and racks of terminal equipment, and spectrum analyzers, and I don't know if I'll ever achieve that again in my lifetime.
Let's see. Can you think of anything else to go over with this AM radio video, or?
Well, the one other thing was shown there is, the ground rods were spaced at intervals of 6,000 feet. There's also a DC component to this, in that the potential of the Earth at one spot is not the same as the potential of the Earth at another spot. That all the various types of rocks and veins of rocks and soils and all these things create the Earth also has kind of like a battery structure. So there's always this migration of galvanic electricity moving around inside the Earth, which is a whole study in its own, is the DC component and the slow variations rather than the audio part. And that's one that I have not really engaged in yet, but at that particular point in the cable, the idea was to measure all those components and then show, these are all the various factors that exist that have to be studied. Mm-hmm. And it's something the telephone company has to take into consideration, is if you have two toll exchanges that are separated by 150 miles, is the electric potential of the Earth can be very different at one system than it can be at another system, and cause very undesirable circulating currents to flow through the telephone wires connecting in between. This is a big problem, long-distance telephone.
Is there enough electricity there between those with the DC component to light some LEDs or something, or draw anything usable off of it?
Yeah, actually, there is a small usable amount of power. In the early telegraph days, they used dowsers to find the best grounding spot for the grounded type of telegraph system with only one aerial wire. And there were incidences of telegraph systems that powered themselves. And during magnetic storms in the Earth, which produce large earth currents, in long-distance power lines, which are some of the longest transmission structures, they can be 800 or 1,000 miles long, the currents can reach enormous magnitude and saturate the cores of the transformer and knock the entire electrical system out. And an example of the intensity that earth currents can reach, the observations that were made with the Landers earthquake, which was kind of convenient that we had an earthquake right there, one of California's biggest, is one of our guys, Carl, was an electronics technician, and he repaired people's TVs and fixed their circuit breaker boxes and all that kind of stuff. He was kind of the main guy there in the Yucca Valley, 29 Palms area. After the earthquake, he got all these calls of people. The colors were all blurred and shipped for TVs. And what had happened was the earth currents reached such an enormous magnitude and had such serious transients in them that it permanently magnetized the insides of the color television tubes and rendered them useless. And at that point, you would find, like your tools would be magnetized, and and hardware, nails and stuff would all become magnetic in a situation like that. So the town of Yucca Valley got magnetized out of the earthquake. That could be the consequence of earth current up to the megaamp range. Uh-huh. So that's why you start to see all these lights and other things start to happen before earthquakes, and there's lots of illumination during the earthquakes. There's massive movements of electricity involved, orders of multi-megawatts.
Okay, well, thank you for that, Eric. I think people find this pretty fascinating, watching the demos. They're about 5 minutes each, and following this, it'll be the first one where you connect the ground lines around the radio and suddenly are picking up stations just all across the band. And the second video is also about 5 minutes long, and that shows a couple things where you're testing it, and you're using Steve McGreevy's device, to that electrostatic receiver, to listen to some of those signals. So anyway, thank you very much, and we hope the campaign to be another success.
Okay, thank you.
With no hookup.
7. Stay on.
Okay, and then we're going to connect in series with the cable ground.
Three-day vacation to vacation. Call Heritage for the Blind right now. 77. Call now. 1-800. From the beginning.
There you go. Total ground reception.
You take your 6-year-old to the playground. Sending a text. Shoes like you've never seen.
Okay, that's good on that. So, that's this ground rod. Potential difference against the mountaintop. And this is this ground rod's potential difference to the one down by the wash. And then the difference between them from the mountaintop to the wash. They're much closer polarity. So this spot has got the highest potential difference. And we can go to resistance. So that's the resistance of that ground rod down in the wash against station ground. And that's the one down the wash against this ground, which is closer. The station ground is more solid. And then this ground rod, station ground, is pretty well connected because we're close to it. Let's see what kind of lightning noise there is. I think today's a very quiet day. Yeah, hardly anything. Oh, where's the dog? You going to get the dog to come here? Let's see what kind of sound the dog makes. Come here. Come here. Jagginess. Electrodog. Yep. Electrodog. So there's quiet. Okay, now the little amplifier. Power line noise everywhere. That's from the building. That's the distant ground rod. We're starting to get some signals on that one. Okay, let's do a pair. Yeah, little squeakers are in there. Pretty hard to hear much anything. It's so quiet today. It just crack. The lightnings are crackling. What's this? Got lots of signal too. Low pass filter, high pass. Okay, well that's about all we can get out of this. AM radio was the main thing.
Not the case. There's a longitudinal dielectric wave that transmits from the ground system, the AM radio station, into the Earth. And my crystal radio initiative that I started on the energetic form was aimed at actually extracting useful power, as in the Tesla wireless power transmission mode, from AM radio station and the town of the person doing the experiments, and people were capable of lighting small light bulbs and running very small motors off of power extracted from the transmitter at the AM radio station transmitter site, which basically vindicates Tesla's conception of telluric transmission.
Now, when powering the light bulbs from this ground component from the AM radio transmission from the station, would that be drawing a load on the station? Like the station
Yeah.
would be?
It'd be insignificant because the station, is typically putting between 5 and 50,000 watts into its antenna. The bulk of that power is consumed as energy, wasted by electromagnetic radiation in the space. But the Earth component is not necessarily in that it receives the magnetic field, but it is not receiving the electrostatic part of the electromagnetic wave, just the magnetic part. So it's a compromise antenna. But it has hundreds of turns on it, and it has a concentration core of magnetizable material that effectively makes it a 1,000-foot wavelength device. So when this thing's held up, you can take any pocket radio and you'll observe that as you turn it, there'll be a dead spot when the windings on the coil are not in line with the tower at the AM station. Then if you turn it 90 degrees, it comes in good. So that's kind of shown first with the radio above ground and limited reception available. There's several stations of moderate strength. Then after that, the telephone cable that's being paired out and worked on and refurbished, there's two 6,000-foot sections called H loading sections. And it's a ground rod on the end of each one, and then
different points on there, and then it looks like you have one of Steve McGreevy's devices that you're using to listen to some signals. So what are people seeing in the video clip where you have some wire wrapped around the AM radio and you connect it to the ground line?
Okay, what's going on there is first the AM radio was shown to be receiving in its normal mode. Some explanation is required. That the AM broadcast band operates what's called medium wave or medium frequency. The wavelengths are fairly long, like 1,000 feet or so. And basically the medium wave band is defined as being between 300 kilocycles and 3,000 kilocycles. So 1 megacycle is in the middle of the AM radio band. So it has a coil inside of it because there's no way to build the structure of that wavelength size to receive electromagnetically. So the handheld AM radio, pocket radio, receives magnostatically, to use a technical term for.
Okay, this is March 30th, 2015, and this is Aaron Murakami on the phone with Eric Dollard. Can you hear me okay, Eric?
Yeah, if you speak up a little louder or closer, it'd be better.
Okay. So the purpose of this call is we'll put this talk on the Indiegogo campaign so people can understand what this AM radio experiment is about and why it's relevant to the seismic project. Now, first of all, I have 2 video clips that I got from Justin. One shows you with a little handheld pocket radio tuned to the AM band, and it has some wire wrapped around it, and then you connect it to some ground lines, and suddenly there's like a channel on, every single frequency as you're thumbing through the stations, which wasn't there before. And then there's a second video where you're doing some tests. Looks like you're doing using an ohm meter to check the resistance between.
What I do is I take a piece of wire and I connect the shield of the eastbound cable to the shield of the westbound cable and make a loop to create a magnetic field, and then immerse the coil of the AM radio in that magnetic field. So now the AM radio is magnetically coupled to 12,000 feet of underground facility, and then it's noticed that the AM radio receives all stations, all channels are full, the full volume, and this is done with the cable that's buried 18 inches to 3 feet in the ground.
Mm-hmm.
So it demonstrates pretty clearly that there's a very strong underground component to the AM radio broadcast.
Which is not typically known.
No. That's that particular element of AM broadcasting is in the Tesla mode, and that mode has been stated by the Einsteiners as to not exist whatsoever. So the entire wave is conceived as being external to the Earth, but that's actually